Hi, you guys. So in the previous lessons, we were talking about similar triangles and the different parts of those, their special features, and things like that, particularly about their proportional parts. So remember, in similar triangles, all of their sides are going to be proportional to each other. So in this lesson, we're going to talk a little bit more about proportional parts. Specifically, we're going to talk about how we can find proportional parts in relation to parallel lines. So we have a couple different ideas that we can talk about with this. So the first idea is that let's say we have this triangle ABC, and then on this triangle we have the segment DE. So DE goes through AC and BC respectively. Now, if we're told that AB is parallel to DE, then that tells us a special little feature of proportionality. So what it comes out to be is that if we're told that AB is parallel to DE, then that means that this segment is to this segment, so AD is to DC, as BE is to EC. And we see that up here. So this segment is to this segment, as this segment is to this segment. So we can set a proportion, and if we knew the values of these lengths, then we could plug in those values, maybe figure out unknown lengths. So as something we had talked about in the previous video, we had talked about how when we are looking at similar triangles, so if you're looking at the two triangles that are shown here, so in this triangle we do have ABC and then another triangle of DEC. So if we're looking at these in the sense that they are similar triangles, then if we were wanting to compare lengths, then we'd have to use the full length of AC if we're comparing it to DC. But if we're just looking at the idea of that these are parallel lines and we're wanting to compare these opposite sides, so this segment to this segment, this segment to this segment, or this segment to this segment equals this segment to this segment, then we can just use the opposite the segments, not the full lengths. And actually, we want to use the just the segments rather than the full lengths of AC or BC when we're doing it like this. So that can be a little tricky remembering when to use which one. But remember, if you're doing it in terms of the fact that they're similar triangles, then you're going to use the full length. But if you're doing it in the sense just because the DE is parallel to AB, then you're just using the individual segments. So, as I said, the theorem here is that if we're told that DE is parallel to AB, then that means that AD is to DC as BE is to EC. So those segments are going to be proportional. Sort of with that, we also have the converse of that idea. So if you remember what a converse is, it's sort of the opposite of the original statement. So what the converse says is that if we've been told that AD is to DC as BE is to EC, so if this proportion right here is true, then that'll tell us that DE is parallel to AB. So if we hadn't already been told that these were parallel, then we would have been able to prove it due to the idea that these segments are proportional. So those can sort of go hand in hand in helping you determine unknown things. So say if you're asked to determine if these two lines are parallel, then you could use this idea. Or if you're told that these are parallel, then you can use this idea to help you find missing links. So another idea that sort of goes along with these is when we're talking about mid-segments of a triangle. So we've previously learned about mid-segments with other shapes, but when we're talking about a mid-segment of a triangle, it's basically that if we're saying that DE is the mid-segment on this triangle, that means that AD is equal to DC and that BE is equal to EC. So it bisects these two lines. And so when we have a mid-segment, basically what that can tell us under the sort of definitions of a mid-segment, the mid-segment is going to be parallel to its respective base. So since it goes through AC and BC, its base is going to be AB. So if DE is the midsegment of this triangle with AB as the base, that means that DE and AB are going to be parallel. And then sort of in correlation with that, the length of the midsegment, so the length of DE, is going to be half the length of its respective base. So the length of DE is half of the length of AB. So when you're looking at say if you were asked to find the measurement of DE and you knew how long AB was, that could help you figure that out using the idea that this midsegment is 1/2 of that length. And then also remember that a triangle has 3 different midsegments. So we also have one right there and one right there. So with all of the different sides, they have their own respective midsegment. So sometimes when you have a triangle that looks like this, and you have to use the different ideas that come from that to help you figure it out. All right, and then just one more idea that sort of goes along with all of this. So going a little more further into specifically parallel lines, let's say we have these 3 set of parallel lines. We have A, E, B, F, and C, G. So these 3 lines, we're told that they are parallel. We create all these different segments. And so let's say we have this situation. We have a theorem that can tell us that essentially these transversals are going to be split up into segments that are proportional. So if we have these 3 parallel lines and these 2 transversals, then AB is going to be to BC as EF is to FG. So the ratio of AB to BC is the same as the ratio to EF to FG. So again, we have proportions. So let's say we knew 3 of these lengths and we wanted to know what EF was. We could plug in our respective values and then solve the proportion to figure out what EF is. And then sort of under the same idea, and it can sort of fall under the logic of this, but say we were told that we have the conditions here already in place, but then we were also told that AB is equal or is congruent to BC. That would sort of use the ideas here, because if you think if these 2 are equal, that means the ratio is going to be 1. That tells us that EF is going to be congruent to FG. So since the ratio here was 1, that would mean that the ratio here would also have to be 1. So if we have already been told that this is congruent to this, then that means this is congruent to this. Common mistake that people will do is they will see the situation and they'll automatically think that these lines are going to be congruent. However, we have to be told that one set is going to be congruent. And this picture does look like they are in fact congruent, but that won't always be the case. So you do need to look out for things like that. But these are the basic ideas of this lesson. So if you have a triangle with a segment going through it, this segment and this segment are going, or this segment and this side are parallel, then that means it splits the other sides into proportional parts. And again, unless we're told that DE is a midsegment, we don't know that these sides are going to be congruent, but since we do know they're proportional, we can set things into a proportion and solve. And the converse of that is also true. If we're told that these respective segments are proportional, then that means that these lines are parallel. And then additionally, if we're looking at a midsegment of a triangle, it's parallel to its base and it's 1/2 the length of its base. And then over here, if we have these 3 lines and these 2 transversals can go in whatever direction as long as they're not parallel to these other lines. These transversals are split up into segments that are proportional. And then sort of using that further idea, if AB is congruent to BC, that means that EF is congruent to FG. Alright, so now sort of putting some of these ideas into practice. Let's say we're given this triangle here, and we have these various segments going through it, and we are told that this is congruent to this, this is congruent to this one, and then this is congruent to this. And then in addition to that, told that this angle right here is 52 degrees, and we're told that this angle right here is x. And we want to determine what x equals. So we have various ideas going on through here. So, but sort of using some of the ideas of what we learned in the different theorems, you can sort of look at what exactly we're being told. So we haven't actually been told that anything is parallel. We haven't necessarily been told that anything is proportional yet. So we can't really use any of the ideas from the first set of things. Remember, we had the idea of if a segment and a side were parallel, then sides are going to be proportional, or segments of the sides are going to be proportional. And we have had the ideas of mid-segments, and then we had the idea of three parallel lines create proportional segments. So we haven't been told that anything is parallel, and we haven't been told that anything is proportional, so we can't use that first set of ideas. However, if we're looking at this, we see that D is the midpoint of MK, E is the midpoint of LK, and F is the midpoint of ML. So what does that tell us? Well, using the definition of the word, that means that these segments here are going to be mid-segments of the triangle. So if we remember what our ideas of the mid-segment are, it tells us that a mid-segment is parallel to its respective base and that it's 1/2 the length of its base. So we're not dealing with any lengths, we're just trying to find this angle measurement, so we can sort of ignore the second half of that. But we can use the idea that segments are going to be parallel. Specifically, we're going to look at the idea that this segment is parallel to this line. So, since that this line and this line right here are parallel, that makes EF a transversal. And we see that our two known angles, or at least somewhat known angles, this one right here and this one right here, they are alternate interior angles. And if you remember your ideas of alternate interior angles, if you have two parallel lines and a transversal, their alternate interior line or alternate interior angles are going to be congruent. So in turn, that tells us that x equals 52 degrees. So that's just sort of an example of how we can use some of these ideas to help us find unknown values. And then sort of going on, we won't do a problem with this, but sort of using these ideas, a lot of these have to do with the fact that we end up getting proportional segments. So let's say we wanted to find DK, we knew DM, EL, and EK. So because these two lines are parallel, we know these segments would be proportional. So then we would be able to use the ideas from our first set of ideas to help us determine what these lengths are, because if these two lines are parallel, that means that this side is to this side as this side is to this side, so they're going to be proportional. So just using those various ideas sort of in correlation to the other ideas we've learned, they can help us put together different ideas and build up our knowledge and build up the tools that we have in order to find unknown values. So those are the general ideas. If you have any questions, let me know. Other than that, bye.